In our first video, we went over some terms. Now we're going to put those to use and talk about some examples of problems that you might be seeing. So example number 1, name line AB in another way. Now notice, when we didn't really go over notation of a line. We've got point A, point B, and above it there's a line with the 2 arrows there. That means we are in fact talking about a line, not a segment, not a ray, the line AB. When we look at our diagram here, we can see this large plane, kind of the flat surface, and a few lines going across it. When we are asked for line AB, we're talking about this line that goes through point A and point B. So we're asked to name line AB in another way. Well, we need to think what other points are on there that we can use. We have A, B, and way over here we also have C. So to rename AB, we can either just put those in a different order or use a different letter altogether. So you really only need to write one of these down, but I'm going to use all 6 possible names here. So you can go A to B, that makes a line, B to C, here to here, A to C, that's the same line, C to A, C to B, or B to A. So all 6 of these, 1, 2, 3, 4, 5, 6, these are all possible ways to name this line right here. They all mean the same thing. Example 2 then, give 2 other names for plane Q. So notice this flat surface, we've called it Q. It's the plane that we are in. Again, remember it technically goes on forever in all directions. It's just one large flat surface. And you can kind of see how this line comes right through the middle of it. It comes down, stabs through the middle, and then comes through the bottom. That's what these dashed lines mean. And then continues on. We can kind of see it underneath. Okay, again, geometry can be very abstract, so you need to picture in your mind or think, here's the plane, this is kind of like a big pencil that sticks through the middle of that flat surface or that flat paper and then comes out the bottom. So, what are some other ways that we can name plane Q? Well, you don't necessarily need to call it by plane Q. You can name it by 3 points that are on there. Now those 3 points, though, have to specifically or only make that plane. And I'll show you what I mean by that. So we can call it plane ABD. We can call it plane DBC, ECD. A lot of them we're using B to name it. We don't have to use B. You just have to use 3 different points that aren't in the same straight line. Right? So any 3 points that don't go, again, straight in a line together, you can use those 3 to name this plane. Okay? Question number 3 kind of gets at, well, how come we can't use 3 points that are in a straight line? And it'll be kind of weird to think about, so why isn't EBD an acceptable name for plane Q? EBD. And we're going to go over the reason here. Since E, B, and D form a straight line, remember that means they are collinear, form a straight line together, there are infinite amounts of planes that could pass through these 3 points, so plane Q isn't unique, because 1, 2, 3 points. Now technically this flat surface would go through these 3, but you could also twist it. You could turn the whole plane around these 3 points. And to kind of give you an idea of what that means, pretend there are 3 marbles floating in space. One here, here, and here. And you can put a flat piece of paper that touches these 2, but it would be allowed to tilt around this axis. Right? So it could tilt to the left side, it could tilt to the right. There are a million different orientations for that paper that would still be touching these 3. Versus, if I, let's look at like plane ABD. If I put a marble here, here, and here, there would only be one flat surface that I could place on top of that, right? Because it's not going to move left or right. There are 3 points for it to kind of stay on top of and lay flat on. So because they are not in a straight line, I can use those 3. So basically any of these 3 that are not in a straight line can be used to name plane Q. So that was kind of going over just renaming some things. Let's go over some attributes. Are A, B, and C collinear? So we look at A to B to C. Are those going to be collinear? Yes, because they are in line AB, AC, BC, however you want to view it. Remember all of these up here that we used to name it, A, B, and C, all lie on that line, so they are collinear. Now on these, I forgot to put the little arrows on top, that little line with the arrows. So if you just say physically this word line AB, line AC, line BC, still means the same thing. It's probably easier just to write it in your answers like this. Put a line with the arrows over the top, BC, line BC, or line CB. Go on to question 5. Are A, B, and E collinear? A, B, and E. Now again, collinear means, is it possible to draw one straight line through those three? No, it is not. A, B, and E, they're all on the same flat surface. They're all in the same plane, plane Q, but they're not on the same straight line. So these are not collinear. Question 6, are A, B, and D coplanar? A, B, D. Coplanar means, are they in the same plane, the same flat surface? And of course, yes, they are. It's in plane Q. This is just kind of the overall name for it, plane Q. That's the plane that they're in. They are coplanar. Now, I don't really like the wording of 7 and 8, so we're going to be a little more specific with these first. I want you to write down a number 9 and a number 10. Number 9 are A, B, F, and D, all 4 of these points, coplanar. So A, B, F, this one way down here, and D. Are these all coplanar, as in are they in the same plane? And we can say for that one, no. No, they are not. A, B, and D are in the same plane up here, but F is way below it. So it's not in the same plane, the same flat surface that these ones are. So these 4 together are not coplanar. Again, these could or should have the little line thing above them. You can put that there if you want. Our lines AB, BF, and ED coplanar. Are all of these lines in the same flat surface? So AB is this line here, BF is this line here, and ED is this line here. Are these all in the same flat surface? And again, that's a pretty simple no. No, they are not. We can see that they don't lie on the same flat surface. So no, they are definitely not coplanar. Let's go back to number 7 then. Are A, B, and F coplanar? In this drawing, they don't necessarily look coplanar. They don't look like they're in the same plane Q. But technically, yes, they are technically in a plane called ABF. So if we put a flat sheet of paper, it could touch A, B, and F together, and it would, again, technically, they would be coplanar. Now again, in this drawing, they are not on the same flat surface, but there is a flat surface that exists that we could put A, B, and F in. So are A, B, and F coplanar? Yes, technically, and it's in this plane. They're kind of their own flat surface. Are lines AB and BF coplanar? Again, technically, yes, they are in that same plane, A, B, and F. So again, it looks like here is AB, here is BF. It looks like they're not in the same flat surface, but if you just kind of tilted everything, there is a flat surface. There's one piece of paper where we could put this line and this line on. It would just be tilted, but it would fit both of them on there, so they're technically, yes, they are coplanar. So again, there are some kind of technicalities, some specifics that you must be aware of in geometry. It is a little more abstract than some of the things we've dealt with before. We're going to keep going with some examples. Find the intersection of the following lines and planes in the figure. Now this figure, it's just a box. It might be kind of hard to see, but technically these solid lines here, those are pieces of the box that you can see. This is just a 3D figure, and then these dashed lines are lines that you're not supposed to be able to see. They're kind of behind the box. So this is supposed to be a big 3D box. Now again, we know that a box will have 6 sides, so there's one plane up here, there's one plane down here. There's one front, there's one back, there's this one that's a side, and then there's kind of this side in the back. So there are technically 6 planes that all intersect to make this box. So we are just looking at the intersection of different lines and planes in this figure. So question 1 says line GK and line LG. So from G to K, that's going to be, I'm going to grab a red pen, to this line right here, and then line L to G. Now again, because technically these are lines, they're going to go on forever. Where do these 2 lines cross? They cross right here at a point, and it looks like that point happens to be G. It's point G where those 2 would cross each other. Let me get rid of these. Oops, I want to keep that one gone. Planes GLM and LPN. So GLM looks like it is kind of this top piece. Okay, that is the top plane, GLM. Then LPN kind of looks like this front piece of the box. So where does the top side and the front side, where do they cross each other? Where do they intersect? Looks like it's this edge of the box is the only spot where they touch. What would you call that edge? You would call it line LM. Going from L to M, this line that is created, that's the intersection. Let's get rid of some of these. Line KP. So line KP is right here, and I'm going to kind of go through it. Pretend that it extends forever. And plane KJN. So KJN is kind of that bottom piece that it's really, really hard to see. Right? It's supposed to be underneath everything. So where does the bottom side and this edge, where do they touch? Well, it might be kind of goofy to think about it, but technically they touch right on that edge. They touch at the line KP. So the only places where this plane and this line touch are this line. Now lastly, let's go over some notation. Just how should you draw things, or how things are going to look. You don't necessarily have to draw this figure. If you would like to, if that helps, go ahead, because this is how a lot of your problems are going to end up looking. Now I drew kind of a goofy looking figure. It's got a triangle on top and it looks like a trapezoid on bottom. So there are a lot of lines, a lot of sides to this thing. But we can learn a lot of things about all of these segments. So congruent segments basically mean segments that are equal to each other. They're the same length, but they're not the same exact spot. So congruent segments would be like A to B and B to C. A to B is the same length as B to C. Now when you look at it on the picture, notice that these 2 marks and these 2 marks are drawn right on there. That's to tell you that in this picture, A to B is the same length as B to C. If this was 4 feet long, this would be 4 feet long. If this was 3 inches long, this would be 3 inches long. They have to be. Now we don't use an equal sign. It looks like an equal sign with an extra little squiggle on top. That means congruent. So segment AB is congruent to segment BC right here. Now somewhere else on here we've drawn 2 little tick marks like that. Actually these ones are just one tick mark here and 1 tick mark here. Now notice that these ones have 2, saying that these 2 are the same. These just have 1, so it means that these ones are the same. And because these have 2 and these only have 1, they're different lengths. So they're not exactly the same size, but these 2 are the same, these 2 are the same. So if you wanted to write that down, you would write segment BD from here to here is congruent to segment CE from here to here. This is the same length as this. That's how you would write congruent segments. Again, just means they're the same length. Congruent angles. Congruent angles means it's the same degree measure. If one is 60 degrees, the other one is also 60 degrees. And there are a couple different ways you can draw that. In writing, if you're going to write it out though, it looks something like this. Angle, we have to use that angle symbol, BDE. So from B to D, to E. This angle is congruent to, we use the same congruent symbol, angle CDE, or sorry, CED. So CED. Notice when you look at those, this one kind of has two swoops right here, and this one has two swoops. Again, those double swoops just mean this one is the same as this one. Now, if you wanted, you could put a third swoop on this one and a third swoop on this one. It's kind of like how one tick is the same as one tick, two ticks is the same as two ticks, two swoops is the same as two swoops, or three swoops. However many you put, those just say these are the same angle measurement. Now again, there's kind of a different way to do it. Look up here. This angle has one swoop with a tick mark through it. This angle has one swoop with a tick mark through it. So that's another way. Instead of doing 1, 2 swoops, just different numbers, you can also put a swoop with a tick mark through it, or a differing number of tick marks to say that they are congruent as well. And again, you write it as angle DBC, so going from here to here to here. This angle, looks like right here, is congruent to angle ECB. ECB. This angle is the same as this angle. If this one was 100 degrees, this one would also be 100 degrees. It just means they measure the exact same. Again, kind of like being equal, we don't use the equal sign, you have to use this congruent sign. Parallel. Now if we look at this, parallel, remember, means that they will never intersect. They never touch each other. Now there are a few lines on here, but really there's only one pair of parallel lines. This up and down one looks like it crosses this one here. It would cross this one here. It already crosses this one here. If we continued this line going on forever, it looks like it would hit way up here. If we continued this line forever, it looks like it would hit down here. So this line is not parallel to anything. Okay? But on the picture you can see there's a little arrow, just one arrow, and another one right here. That's the symbol for parallel. That means these will never ever touch. So get rid of that. Segment BC, or I guess technically we could also call it a line from B to C, is parallel. You just use those two bars up and down like that to say parallel. BC is parallel to DE. This line, oops, just this line here will never touch this line. And that's all you write for parallel. Now again, you might also see it with maybe there's a second arrow and a second arrow. That means these two are parallel. And I know these are not parallel, but I'm going to draw it like this and we'll pretend that these two were. If these each have one arrow and this has two arrows on each, that's saying that these two are parallel to each other and these two are parallel to each other. So it depends on how many little arrows are on the picture. We'll get rid of all of those. Okay, so we've gone over most of these. The last one we have to look at is perpendicular. The only spot where we have some perpendicular lines drawn in is this AB is perpendicular to BC. Notice it has that little box right there. That box means it's a right angle, makes a 90-degree angle. Since these two meet at a 90-degree angle, they are perpendicular. To say perpendicular, you have to use that upside down T right there. So this is our notation. The big main things I want you to take from this are this sign right here, that's congruent. This sign right here, that is parallel. This one's parallel. And this sign right here, that is perpendicular. Okay? If you know what these mean when they're written down and what these mean on your picture, that's the basic geometric notation that you need. And that should cover it.